Number 13 says, standard aluminum soft drink cans do not vary in the amount of aluminum that they contain. 50% of the aluminum contained in a certain group M of standard aluminum soft drink cans was recycled from another group L of used standard aluminum soft drink cans. Group L is coming into the factory, being made into group M, and group M is 50% made of group L. 50% of what's in M came from L. So we don't know how big group M is yet, we don't know how big group L is yet, but we do know that group M came from, half of what's in group M came from group L. Okay, since all the cans in L were recycled into cans in M, and since the amount of material other than aluminum in an aluminum can is negligible, that means we can just totally ignore it. Okay, so we can just say now that the cans are 100% aluminum. It follows that M contains twice as many cans as L. And it sounds reasonable as far as it goes. These are standard aluminum soft drink cans, so I think we can assume that they're the same size. Group M is made from group L. 50% of what's in M comes from L. All the cans of L were recycled into cans in M, so 100% of what was in L went into M. And the conclusion is, so M has to have twice as many cans as L. It sounds really good, but there apparently is a missing piece because the question stem here says the conclusion of the argument follows logically if which one of the following is assumed. That's a sufficient assumption question stem. Sufficient assumption questions are asking you which one of the 5 answer choices, if true, will prove the conclusion of the argument to be correct. In other words, the conclusion of the argument is not yet proven to be correct. There is something missing. It can be hard to see sometimes on a question like this. It sure looks like, the argument to me looks pretty solid. It looks like it has already been proven. And when I first read it, I actually struggled for a minute because I thought that it had been proven. I was like, oh, well, that argument is sound. But the question stem says, no, it's not. The question stem says, hey, there's a sufficient assumption in A, B, C, D, or E, which makes me think, oh, well, what could possibly be wrong with this argument? What could possibly be missing? And I think what could possibly be missing is maybe when you recycle a can, there might be some loss that happens. So I get it that all of the cans in L were recycled, and whatever we got out of that went into M. But what if when you recycle a can, you only are able to reclaim 75% of the aluminum? If that were the case, then there wouldn't be twice as many cans in M as L. There would be less than twice as many cans in M as L, if there's loss. So I'm looking for an answer now that says nothing is lost in the recycling process. I think if nothing is lost in the recycling process, then the conclusion would actually be justified. Sufficient assumption questions, I'm going to try my best to make a good, strong prediction before I look at the answers. 95% of the time, I'm going to be able to tell you exactly what the answer is on a sufficient assumption question before I look at the answers. They'll get a lot easier if you start doing that. You got to force yourself to predict the answer. So I think I've done it. Let me see. A, the aluminum in the cans of M cannot be recycled further. Irrelevant. Who cares? What happens after they leave the factory is not even relevant. B, recycled aluminum is of poorer quality than unrecycled aluminum. Maybe true in real life, maybe not, I don't know, but has nothing to do with whether there are twice as many cans in M as in L. Quality, not relevant to the argument. C, all of the aluminum in an aluminum can is recovered when the can is recycled, and that's exactly the answer. That's what was missing. If you add that to the existing evidence, then the conclusion of the argument is proven to be correct. So C is a sufficient assumption of the argument. D says, none of the soft drink cans in group L had been made from recycled aluminum, not relevant. E, aluminum soft drink cans are more easily recycled. The ease of recycling is not relevant either. So the answer there is C.